In this video, we will be using the graphing calculator to calculate the correlation coefficient, the coefficient of determination, our least squares regression line, and we're going to interpret those values obtained. So first we need to enter our data into the calculator. We would press Stat, select option number 1 for edit. If you have any data in your calculator, you can move your cursor to the very top, press clear, and then enter to clear any previously stored data. In L1, we're going to type in all of our X values and press enter between. In L2, we're going to enter all of our Y values. To get back to our main screen, we want to press quit. Anything that's above a button, we need to press second and that corresponding button. Now we want to make sure that our diagnostic tool is on. We're going to go to catalog, which is right above 0. Once again, anytime you want to access anything above a button, we press second. We can scroll down until we get down to diagnostic, or since the alpha setting is turned on, we can just press this button to access letter D, and it will jump down to all the options that begin with D. And we want to turn our diagnostic on, so we're going to press enter twice. Now, to access any of these features, we would go to Stat, we would go over to Calculate, we want option number 4, Linear Regression. Since our data is in L1 and L2, those are the original settings, so we do not have to enter in our lists. We can just press enter. If you have the new operating system, just make sure X list has L1, Y list has L2, and you can come down to calculate. So we are given these values. R can be lowercase or uppercase, it depends on your textbook and the settings. So R, the very last line, is our correlation coefficient, 0.83. So this means there is a positive relationship, and it is fairly strong because it's close to 1. Our coefficient of determination, R squared, is right above that value, 0.69. So the way we interpret this, we change this decimal to a percentage by multiplying by 100. So our interpretation is 69% of the variation in Y is explained by the least squares regression line. If you have real world data and there are actually names here for these variables, you would replace Y with whatever that variable name is. Our least squares regression line is provided by these coefficients of A and B, and at the very top it indicates how you're supposed to enter these values. So we have 1.55 as our slope, and our y-intercept 4.17. In order to interpret our slope, we say for every 1 point increase in x, and if this is a real world application problem and you have an actual title here, replace x with that title. So for every 1 point increase in x, y is going to increase, in this case, because our slope is positive, by 1.55 on average. Our y-intercept is 4.17, and you have to be very careful with your interpretation here. There are 2 things you have to pay attention to. You have to ask ourselves, is 0 a possible answer for x? And do you have any x values remotely close to 0 as well? Since we do, you have -4, -1, and 4, 0 is a possible option. So for our interpretation, the value of the response variable, which is y, when the value of the explanatory variable, which is also known as your x, is 0. We can also create a scatter plot for this data. We would go to our stat plot. Anything that's above a button, press second. We want to go to option number 1. Make sure your plot is on. You know it's on if the black box is around on. Our type, we want the very first setting, that is our scatter plot. X list L1, Y list L2. We want to press zoom. and then scroll down to option number 9, zoom stat. And here's our corresponding scatter plot.